Thank you very much for being here. I know there are lots of options, a lot of things you're doing. But it's a real pleasure to be here, to be talking about some of the work we have been doing in the last, I would say about 5 to 7 years, where we have been taking concepts from computer science, video imagery, video gaming, and actually putting that into weather forecasting and trying to do something with regional climate. So it's really sort of like blurring the lines between, as we have been hearing about virtual reality and gaming, we are sort of using that technology to try and see how we can improve forecasts that matter at scales where we are, in your neighborhood, at street level, and so forth. So this is by design a broad talk, but if there are aspects that you would like to discuss further, I'll be obviously quite delighted to follow up. I would also like to acknowledge my co-presenter, Daniel Aliaga, with whom we have been having several National Science Foundation projects, sort of interfacing the computer science world with the meteorological world and putting these ideas together. So I'm going to try and share some of these ideas with regards to what we think is happening in terms of how cities are shaping climate. That's our first part. And second would be, how do we then start using this information in trying to design cities of future? And that wouldn't mean that we essentially eliminate the entire city and restart. But as you can imagine, when you're driving around, cities are undergoing change all the time, whether it's in the roadways, in the waterways, the infrastructure that is being designed. How do we sort of put this information that we have now at our disposal, the knowledge that we have, into this kind of future design? That will be the goal we'll try to achieve in what we are doing with this kind of work. I want you to also be aware of the Purdue peat there, and they are, the boiler maker there. And I'll be bringing that context about why the boiler maker and what Purdue had been thinking about 150 years or 100 years back is still so valid into the future as we go ahead. So cities are important, obviously, because they're drivers of economy. They are seats of culture. That's where we have a lot of our creativity coming through, a lot of branding. When you start thinking about the Bay Area, you start thinking of certain kind of culture. When you start thinking about New Orleans, you start thinking about different kind of food and culture and something. When you think of the Paris and the evenings, you have different ideas that start emerging. So cities are actually quite crucial, because as we speak, more than half the population globally is staying in cities or in urban dwellings. So we are exceptionally urbanized than any other era that has ever been on this earth. And cities truly exemplify what we have seen in terms of technological advances. Everything that is coming in technology is sort of like tested out in cities, is concentrated in cities, and it has led to the development and the growth of cities across the world. We have seen it in terms of why it would be, you could say it's because it's efficient. All things are together, it enhances productivity, it helps people becoming competitive, it stirs up ideas, you have knowledge sharing, you have people coming together, it facilitates creative thinking. When you collaborative process that can going through. In fact, I always think that creative thinking is a highly collaborative process. People share ideas, you start putting ideas together. The more you have coming together, those kind of things start emerging. I mean, the things we are doing here. But in the context of where we are going in the future, cities really are the economic nerve centers for the globe. By some statistics, for $1 that is invested in city, the returns are about 10 times. So it's not a surprise that more and more countries are investing more and more things in cities. They are putting and trying to grow cities such that they can start kicking economy and develop the country's infrastructure, country's opportunities. So at this point, roughly 80% of the global GDP flows through about 500 cities. So cities are really quite important. And if you are more interested, there is this UN Habitat report that sums this out beautifully in terms of where we are. But in the context of where we are with the dawn and doom of technology, cities exemplify everything that is great with technology But at the same time, if technology is not well used, they can easily represent what is wrong with the world today if things are not managed well. I mean, we have all experienced this. The context of urban sprawl, where things have just been growing in an haphazard manner in every particular space that can be inhabited. You can see this almost everywhere in terms of where cities have just been growing in whatever spots that's available. I don't even have to tell you which cities these are. You can probably see these images and these mosaics wherever you go. Pollution and traffic jams. I mean, any city that people are avoiding are in terms of the context of where we are seeing and what kind of traffics are evolving. The pollution that starts emerging, the smog, the health impact, the cost of health impact management because of the pollution that comes from cities, the landfills and so forth. So everything that can be considered wrong in terms of where civilization is trying to do things together can also be found in city. Cities also have this unique problem of the big floods as well as what we call this nuisance flooding, where some cities and the streets are constantly flooded and you have to go around it. You could have some hazards that are being generated. It could be associated with floods that are coming through with more and more development that is coming. You could also have it in the context of the costs emerging with regards to your health, with the heat waves and so forth that is going on there. So the research premise of what we are going to talk about is that the computational technology, as we are trying to do here, if blended with good scientific understanding, such as from the meteorological processes that we are using, we can develop tools, and these tools can perhaps be used for predicting and managing these high impact weather events. We can perhaps use this knowledge to make our cities a bit more climate ready, if you will, and then try and use this in terms of developing our infrastructure and designing future cities, or the cities of future that are ready for the future. So that's the premise. It sort of builds on this idea that when we have data and evidence, building off that some knowledge can follow. But when you have this data and tools, then some knowledge-based action can follow or decisions can follow. So simply saying that we know this, there are a lot of people trying to do good things, but if they don't have the right tools or the right ways of doing it, they will not find a way of implementing it in terms of their decision making. So the idea here is collection of data and development of tools, and then using this together to try and see how we can create cities, how we can improve forecasting for cities as we go. So before we go in saying we want to design better cities, let's take a moment and think about what is a city. I mean, when you start thinking about a city, I'm sure some ideas start emerging in your mind. Maybe those could be linked with the global city of the world, like New York City, where you could have, buildings, a lot of people, vehicular activity, some green areas like the Central Park there, coastal bodies, and so forth. Yes, indeed. And so one could say that cities is something where we can start seeing this kind of boundary associated with urban infrastructure put together. But there are parts of cities where people actually don't stay in that city alone. Washington, D.C. is a good example, or it's London. If you look at the footprint associated by the city of London, you can see it is probably this much area, contextualized by this darker area here. But there are a lot of people who actually travel into the city and have a mobility around the city, and such have an impact that is associated with the city in an area which is much wider than the footprint associated with that city. So you could have a much larger impact. Or if you start looking at it from the atmospheric sense, you could have cities sort of polluting and emitting things which can go hundreds of miles away, and then create an urban airshed, just like you might have heard about a watershed from where all the water comes together. You can have an airshed in which all the emissions are going into this region around it, which can be hundreds of miles away. So when you're starting to think about a city, don't just think of those small footprints that we have all been used by Google Images, but in fact the network that supports it, the environment that is around it, the whole interlinking that is going on all the time in terms of sustaining that infrastructure, bringing people together, creating that whole living organism that we have in terms of a city alive all the time. So no matter what, it should be apparent that the cities have an influence which are way beyond what is happening with that urban footprint that we're used to. And they have a larger footprint and influence on our environment. That's something I want you to think about. So in the context of the world as we see today, we are growing cities. I mean, yes, we used to have trees, crops, now we grow cities. And that is the new global change that is going on, no matter where you are. And like other global changes where we are trying to curb greenhouse emissions or the CO2 emissions, if you will, we are actually working very effectively in growing cities more and more. So this is a kind of global change that is going to continue in a very large sense. And what I will show is that these cities, this urbanization, as a new global change that is going on, is notably, significantly, detectably modifying our temperature, our rainfall, our hydrology, our greenhouse emissions, and by virtue of all of that, the climate around it. And that's what I'm going to try and show here briefly initially. Much of what we are going to show today is actually a conglomeration of ideas that have emerged, and we had this very large gathering that we convened in New York City called the International Conference on Urban Climate, and where we had about 600 scientists, planners, designers, policymakers come together from over 50 countries and put these ideas together. So this is a growing, emerging field where we are starting to think how cities and climate interact with each other and how we can make resilient cities, cities that are better livable and going together into the future. I'm also going to talk about, in terms of what we have learned with regards to 3 major initiatives I did in my sabbatical last year, where we had a national program trying to understand cities and technologies together, putting computing resources together, and then developing technologies for flood forecasting. And I'll briefly mention about a community effort that even all of you can be involved in, called a World Urban Dataset Analysis and Portal Tool called WOODAPT. You say it a few times, you'll get used to it. WOODAPT, WOODAPT, WOODAPT. Yeah. So this World Urban Dataset that we are developing as a community effort, I'll show you how the citizen science is actually helping improving our technology for urban systems. So first and foremost, why are we studying cities? Why are we concerned about urban climate and weather extremes in the cities? And for that, I have to say, sometimes these things might be obvious, but I've learned that it is very effective when you start stating the obvious. Here's one sign which I learned from. Notice, this store is not open today because it is closed by a manager. No argument, absolutely. It is not open because it is closed, and who is telling this? The manager is telling it, sure. So the same way, I'm going to tell you some things which are fairly obvious to the scientific community, but I would like to still restate them. One, climate is changing. Why, how, who's doing this? We'll not get into that, but things are changing. Stationarity is dead, as some hydrologists will often say, that what was the past is no longer valid for the future. Things are changing. Extreme events are on the rise. We are getting more and more floods, more heat waves, more storms, more hurricanes, and not just in terms of the numbers, the impacts that they are causing, because we are now a community which is much more in terms of people, much more in terms of the abundance we have, and it is all coming together. So more is happening. And economies and cities are more vulnerable than ever before, simply because of the larger size we have, the numbers we have, and the whole combination together. So this is happening. And you can see these examples, whether we are talking about Hurricane Sandy and what it did to New York City, or what the tornado did in the CNN Center in Atlanta, or what was the heat wave in Spain and Europe, or Harvey did to Houston, and Sandy, of course, closing the entire global markets because of the hurricane. So all these things are not unusual in terms of what has happened, but they were exceptionally unusual in terms of what people were thinking, statistically speaking, that these things shouldn't be happening, but they have all been happening. And this is where we have this challenge, that how do we make a city that still thrives without putting all the resources in its infrastructure, because city is not just its infrastructure. It is the services, people, things we do together. How do we do that? So conceptually, when we are trying to look at how do we design cities and climate together, people have essentially, like us, trying to put it in the context of heat waves, that how do we make them thermally resistant, that when we have heat waves, not many people die. In fact, we reduce that count. Second is, how do we avoid floods, urban floods, which have been going on all the while. And more recently, the issue that we are coming up with regards to urban droughts, where cities are running out of water. You might have heard, like Rio and several South American cities, there was this thing, 21 days of water left, 15 days of water left. City of Atlanta, about 5 years, was it, or 7 years back, we had this case where they were going to run out of water under the drought that we had. And there was, in fact, a case going on that they had to release that water as part of the Environmental Act to allow the fish and other things and natural resources to continue. So it becomes a major issue with regards to what we have in terms of the availability of water for a city. So those droughts. And how do we make water available in going droughts as we speak? Here's an example of what we are seeing for monsoon rains. Like I was on a sabbatical last year, as I mentioned, and here you can see a place called Chennai, which could be roughly like Houston, southern India, warm, hot, humid, hazy development going on. So you can think of it in the context. But what is unique is that in about 10 years, that city has quadrupled in terms of its urban footprint in 10 years, just like everywhere. So the same amount of rain that used to percolate into the ground is now no longer able to get into the ground and has to stay there on the concrete surfaces, on the road surfaces. And so when you get more and more such rain, it starts to flood. And that has been like what were routine, quote unquote, monsoonal heavy rains are now becoming flood causing storms. And that's going on. So how do we work together? So the first part we want to understand before we say how we can make cities change the climate is to understand how do cities in the first place change the climate. So for that we have been studying for over multiple years. The most well-known aspect associated with cities is what we know as the urban heat island. Have you guys been aware of that term? Like where cities are warmer than the surrounding area. Here's an example. In the blue line here, you see the temperature for Midway, Chicago, and red is temperature for a place called LaPorte, Indiana, roughly about, I would say, fairly rural, not very urban, but within the same climate zone. And you can see that the temperatures are roughly about 5 degrees different. So this is not climate change. All we have seen is that this is more urban, this is less urban. So because of that, you're going to have a warmer temperatures in the city. If you look at it from a satellite imagery, you start seeing something like this. This is the city of Atlanta. Looking at it from the top, you can see this is the urban area here. This is the forest, the pines and so forth that you have. And if you look at the thermal image, you can see this island-like image, which is the warming of the city. So this is your urban heat island. In fact, if you look at it in terms of a bigger context, these are quote-unquote heat islands that you can see in other parts of the world. Examples of heat islands. So you can emerge that cities really have a lot of heat that is being stored. They have their own activities that go on and so forth. So that's first. But it's very interesting. When cities are getting all that energy and storing all that energy and they're starting to heat up, they're modifying the thermal environment around it. When you change the temperature, it also changes the ability of that air to hold moisture. In winters, you can imagine it's dry skin. You're putting humidifiers because there's less moisture in the air. In summer, you can imagine there's more moisture that can stay in that air. So temperature and humidity starts changing. When your temperature and humidity is starting to change, you have this region which is starting to look quite different, and what we'll call this urban heat dome, if you will. Under that urban heat dome, we have warm air, more moisture, and when you have this warm air and moisture coming together, you have tremendous energy in that kind of system. And that energy then starts creating this heating and convection and thermals. It's like the way you start heating your tea or pass the water and those bubbles start coming up, that air starts coming up and rising up with all the energy it has in it. It takes the moisture around it, it takes all the heat with it, the energy together, and starts creating these beautiful clouds. Yeah, they rain, they cause nuisance, but they're beautiful. Yeah, and those clouds then start creating these thunderstorms. Those thunderstorms can actually then get moved away from the city very often because things don't stay stationary, and they start moving away, and they start raining downwind of the city. So this is the conceptual picture that we can imagine in manner in which cities are changing the temperature, the humidity, the air, the circulation, the clouds, the thunderstorms, and the rain that will emerge downwind of the city. So does this really happen? That was the question we posed. So you can start seeing it in terms of a different way. The city is getting redder and warmer. It is getting all the moisture sucked in, because when it is hot, the pressure is low. High pressure to low pressure air transport, moisture transport, you get a cloud formation, the cloud starts moving away, and it starts raining downwind of the city. So that's the picture we have been working with and trying to understand. So we looked at our own neighborhood, Indianapolis. Urban area, does it rain downwind of Indianapolis differently than over Indianapolis? So this is Indianapolis here, and this is like you might have seen the radar imagery where we are looking at thunderstorms, and you get a National Weather Service has given this severe thunderstorm warning, etc., where you have this radar imagery showing the storms coming through. You can see it here. So we analyze the storms, and you can see that you get more rain downwind of Indianapolis. In fact, we have more intense thunderstorms downwind of Indianapolis, much aligned with the concepts we have from theory and so forth. We actually can understand this using weather models, where unlike in real world, we can put the city, take out the city, recreate that same storm situation, and under that we can see that when that storm is interacting with the city, it becomes more intense. When it is not interacting with the city, that is not there, it stays as a benign system and does not create that intense thunderstorm. So we have been doing this for many years. We have a good understanding that cities change temperature, cities change the environment, cities change the rainfall, and so forth that goes with it. Now you might ask, cities are down here, my cloud rains are up there, miles above. How can a city change something up there? So here's another example in another setting in Australia, where there's a natural experiment that had gone on for many years, where you had agriculture in one region and forest in another region. So it has just been evolving over many years. Now you know it's happening at the surface. But what I want you to watch is how clouds get formed and what happens to the clouds when they start coming to this barrier, or what is known as this bunny fence, which is literally a fence that was put for rabbits to not go into the crops and eat those crops. So what happens to the clouds as they come towards this bunny fence? Okay, so that's what I want you to view. And if you're flying in, this is what you'll see. Agriculture over here, harvested at that point, forest much greener, much darker, has the ability to store all the energy, and you can see clouds that are forming over the forest but not over the agricultural region. Don't take my word for it, you can actually see this. So here's a satellite image. I wish I can reduce the light here. Okay. All right. Is this visible? This is that fence you have to watch. And what you see in this white blob is a satellite image showing the clouds that are coming. And what I want you to pay attention is at that fence and how these clouds behave. So this is a real case, looking down onto the clouds, and watch how the clouds are coming in and they are stopping at that fence. It's like, oh, I can't cross that fence, almost. Here. Look at that intense front just stopping right there. It is not crossing over into that field. In second scenario, you have a sea breeze coming through, and it is coming and it is forming only over the agricultural area and nothing happening over the forested region. Again, stopping right at that barrier where we have this boundary coming through. Another scenario where a front coming and stopping at that boundary and not moving through. So the point I'm trying to make is that these things that are at the surface, they don't have the influence just in terms of the surface features. They in fact manifest and have a powerful force that can change the environment, the storms that are coming, the rainfall that might be emerging, by the very way in which we have designed those boundaries. Whether it is agriculture, forest, a city, or agriculture, how we design those boundaries can well determine where those storms can come and where those storms can travel. So imagine a scenario. You have a watershed that is supplying water to that city here. And you design a city that is growing in this manner over the next 20 years. And by virtue of that, the rain that is going to fall is going to be moved away from that watershed. Is that a smart way of designing a city? Or whether you design a city in which you use this knowledge and make it longer. I'm just giving an example. And now you get more rain coming into that watershed, such that when the city's population grows, your supply of water naturally has grown. Which will you use? Obviously the option 2, because I have just stated option A and option B. But in reality, you have multiple challenges and optimization you're doing, and if you don't have this knowledge or if you don't have this option, you're not going to consider this. And that is where some of this knowledge starts coming together. And we have to state this obvious such that people can start using it perhaps. And that's where we'll start to do. Now, this was over a city. Does this really happen globally? So let's take out another case. There's a very well-known journal called Science. Everything that gets published in Science generally is of very high quality, and it is. So there was this finding that the Indian monsoon is becoming more extreme. Dramatic climate change. This is what is happening. But when you really start looking at what is happening in terms of the change, it is very interesting. All the rain that is really changing is only over those regions where cities are growing. So is it climate change or is it cities? What is changing that rain? And it just so happens that everywhere cities are growing, and so the impacts are tying in together. So can we somehow change our cities to dilute or modify the impacts associated with climate change? That becomes the question. It's happening in our neighborhood too. For instance, this is Chicago. You are seeing Chicago growing in, say, what was the darker it is in 1930s. Then the trains came, and so we had those pokey pattern that started emerging. Then through the years, that area started filling in, and Chicago kept growing. Now you know, downwind of a city, it has to rain more, typically, right? So do we see that? It's very interesting. If you had this suspicion that it rains more on a weekend, it is correct. It does rain more on weekends in Chicago, but it rains away from Chicago, downwind of Chicago. That is because we don't have pollution. We have the heating, we have the ingredients, it changes the clouds, but too much pollution is bad, too little is not good enough, and there's this golden rule where it is sufficient, it can create thunderstorm, rain, and it will do that. So it happens typically on weekend. And so you have more rain occurring downwind of Chicago on weekends. And this fact, scientifically, there is a well-known quote-unquote anomaly which has been named as Laporte anomaly that has been known for years now. So it does affect. So it is not just how you design the city, it is also what kind of policies you have in cities in terms of the pollution that emerges, the greenery that can emerge, and so forth. Oh, this was beautiful. I was actually in this heat wave in India when the roads were melting. This is not a morphed image. This is an actual melting of the tar road and how cities are changing and so forth that can happen. And that's because cities are growing. So I hope I've convinced cities affect climate. Now, knowing that cities affect climate, we ask this question: can we design cities to give us the desired climate? Yeah, maybe you'll not get a Hollywood climate in Indiana, but you can still have something to do with what kind of temperature change will I manage, where and how can I get some rain, some basic aspects. Can I do that? Second, can we use this knowledge that we have from the cities in trying to improve the predictions of things that are uniquely happening in the cities, like urban flooding, localized rain in a region causing economic damages, causing nuisance, and so forth. How do we do that? Or how can we make cities smart such that they become more resilient cities in the face of change that is going on? And how do we sort of interface technology together? That becomes a challenge that we are working with. So what I want you to know is that vulnerability is two things: risk and the exposure. Simply saying there's a risk, but if there is a less chance of that thing happening, you don't have so much vulnerability. If you are exposed to something and there's a high risk it is going to affect, you're going to be vulnerable. Okay? Hurricanes happen, but Indianapolis is lesser vulnerable. So yes, the risk is there, but the exposure is limited. If you're in Miami, you have the risk and the exposure, so you're vulnerable. Okay? So, Purdue, remember, Boilermaker, we are so smart. Think what we have been doing. The global change is that hammer. You cannot control that. But we have these chisels, which are those tools that can deflect the impact associated with that global change. And if we design those right chisels and if we design the right tools, we can change that impact associated with the global change on the communities, on the regions that we are in. And so our challenge here is that we may or may not have the resources available locally to change that hammer, because we need international cooperation and so forth. But we can certainly design those local tools to deflect the impacts associated with global change. And that is where we are going to be working in diverting the impacts associated with the city, making them more resilient. So how do we do this? And that has been what we have been trying to do with regards to our work with the computer scientists and everywhere that we go through. So first foremost, we have been part of this large project that is at City of Chicago, downtown Chicago. They have been putting internet sensors, cameras, temperature sensors in downtown Chicago on many locations and putting all this information together. It's just trying to understand what kind of data we have, what kind of things can be made available, and use this information to develop some knowledge. Remember, data eventually will lead to knowledge, and the knowledge with tools will lead to action. The second way we have been doing this, looking at all the satellite information that is available in terms of population data sets, data that are available from Google Earth-like imagery, if you will, OpenStreetMaps and so forth, putting that information together into what we call that WUDAP. Remember? That World Urban Data Analysis and Portal tool, where we are looking at data sets, we are looking at imagery, and trying to create these new maps of how do you represent cities into models. So this is, for example, one example of how do you represent different types of data sets into the models and so forth. Or you can then start working with video gaming and then use that information to sort of take a benign terrain, start putting some images in there. You can start putting that images with blocks and parcels like you have, and then you have buildings. Now suddenly you have this data which otherwise was coming from a satellite source, and start using that information into a model that becomes the model for that city, for predicting that event. Given that, you can ask this question: if I want to reduce the temperature in Indianapolis by 1 degree, where do I put parks, assuming parks cool the temperature? Where do I put white roofs, assuming white roofs reflect temperature? and radiation, and they can cool. So I can ask this kind of questions in a gaming environment and use that information to create this if-then scenarios that planners can perhaps use. That where can I put parks? What will be the impact of putting white roofs? Will it change the temperature? Will it change my humidity, and so forth? And you can even sort of like, make this kind of aspects available where you say, okay, I have a terrain. I'm going to have the city that starts growing up here. I'm going to create this lake. The water starts coming in. And I'm going to have the city. The city can be, let's say, typically like Indianapolis, an oval shape. It can be tall. No, let's make it short. So you can have these buildings. You can have these heights of the buildings. All this data is pixelated. So it becomes a data that becomes available to your weather model. And that weather model then starts using this information in terms of what it can do in terms of generating the weather around it, the environment around it, the cloud formation that can happen for that city, and so forth. So thus far, initially, we started doing this by the virtue of what had been done with regards to synthetic cities, like idealized scenarios and so forth. So then we started working with the context of where do we start doing this with more realistic cities. So that's where we start putting citizen science together. We say, okay, we can do this in video imaging. We need real data. We need actual buildings, actual people giving us information. So we create this WoodApp. Yeah, you have this data where people go out, start taking pictures, start looking at images, and then you have this information on how cities are changing and so forth. This is not from WoodApp. This is from another exercise called Atlas of Urban Expansion that is at NYU. But it shows you how cities are alive. And I'm just going to run through these few cities quickly. This is Raleigh, North Carolina. Changes, Shanghai. The blue area tells you the urban expansion in about 10 to 15 years, how it has grown. City of Hyderabad in India. Addis Ababa, Ethiopia. South America. Berlin. Singapore. Sydney, where we saw something, and even a place like Kabul, Afghanistan, where in the last 15 years or so, you have this dramatic growth. So the point is, these things are happening. You can see this as live elements of growing, cities growing, buildings coming up, and so forth. We have been taking pictures and images of typical housing from different regions so that we can start putting this in the video imaging of games, like what does a building in South Korea look like? What does a building in Britain looks like? What does a building in Cuba looks like? What does a building in India looks like? What does a typical residential building in China looks like? And so forth. We start putting all this information with all this computational knowledge that is available with the video gamers or the visualization community and create pseudo-synthetic cities. So on the left is a city created by the video gaming or the visualization group, and on the right is the actual satellite image that you see like in OpenStreetMap. Fairly similar, not exact, but fairly similar for the purposes with what we have. So this, for instance, New Orleans. Here you can see this reality is a round, and we created a square. So there are some mismatches, but still you can get fairly similar cities that are now created by that program. And you can see this, say, Chicago. You can see not just the way you can see it, but also in the context of how the cities are, how it grows, use this information in terms of, like this is Toulouse, France, and so forth that you have. And you start putting this information in terms of, wide cities, more canyon information. You can imagine this is like a video game that you have, but use this information into the models and start creating this weather forecast for that synthetic city, which represents, say, Indianapolis or Dublin or Toulouse or Shanghai, and come up with this if-then scenarios about how your temperature can change by 1 degree if you have greening, what happens if you are greening in other part of the city, and so forth, around the city, and so forth as we go. So it can be used for things like city design. It can be used for designing traffic. This, by the way, is an animated image. It's not a real image. It's a computer graphic generated image that starts going into the model, giving you air pollution information, and you start creating information like what could be the CO2 levels, so on and so forth. I've been asked to sum up, and I will end up by saying the problems that we are now working with have been problems that have been known for 50 years and more, the complex system problems, where we need the tools, the ideas, the imagination that we have in different worlds to put it into the real world context. In the context of what we are doing with urban sciences, with urban climate, we are starting to put this behavior, humans, technology all together, such that this information is starting to be now used in terms of weather forecasting, in designing, planning, and so forth as we go together. So I'll end with a positive note that with the right technology, with the right creativity and the ideas that we have together, and the efforts we put behind gaming and playing, we can really create cities that are resilient and ready for the future and continue becoming the seats of intellectual, economic, and just being good places to live across the world. I'll stop there. Thank you very much.
Do you have time for a couple of questions? I have a microphone here if anyone would like to ask or has comments.
What you've put up on screen here, the data, the modeling, that's the easy half of the equation. The hard half of the equation is how do you get the planners, the politicians,
Absolutely.
the finance. Any positive news on that front?
You're absolutely right that it's one thing bringing the horse to the lake, but making it drink, so to say. And what is happening is, like this conference we had in New York, we had about 600 people. Half of them were planners and policymakers and so forth, and so it was actually pretty good. I'm going to be in Hong Kong in December, where we are working with the low-impact architectural design community, the planner community, trying to interface with that. We have a slightly different language, and we're just trying to understand how things put together. But the more we show, we understand, we appreciate, and we can give you something that you might use, I think the more of that will happen. But in other sense, there are some examples in Rotterdam, Netherlands, some Chicago planning, in New York and so forth, where people have actually used elements of something like this, either serendipitously or through known technology, where they have made things that have had a positive impact. So the more examples we see like this, the more will be the template for planners to choose from, and more things can happen. Thank you.
So it seems a little bit like what you're proposing is, to some extent, actually control how the weather works in certain areas. But how do we know that those kinds of controls won't have negative effects on certain ecosystems? For example, if a microorganism is localized to a certain area and they don't get enough water because of the way the city was planned, then it could cause some sort of micro biodiversity disaster.
No, absolutely. I think the point I'm making is we cannot, absolutely cannot, identify every known effect that can happen. One of my favorite movies, Jurassic Park, and the physicist there trying to explain chaos. A drop of water here, one goes here, the same water drop goes somewhere else. We cannot. But in a gaming environment, you can perhaps create many such models and probably have 100 such scenarios, such that smart people like you and others can start looking at these possibilities and try to think, is this realistic? Is this going to happen? Is it being considered? Rather than going in a prescribed set of manuals that exist right now, or let us grow. I mean, many cities right now are just going in the context of bigger is great, and that may not be the way. So we are providing this if-then scenarios such that more complex thinking can start happening.
Hi, sir. I have two questions. So the second part looks very promising, but climate change is a global issue. Your regional strategies may not be that effective. And the first part about cities shaping climate, I mean, isn't that human activities more responsible for the climate change? So modifying the cities will not change the facts. I mean, isn't it more obvious that simply putting more clothes on when weather is cold is more useful?
But where did those clothes come from? You have to have a factory. You have to have a supply chain that created greenhouse emissions. So yes, we are not saying please start wearing T-shirts when you're designing a better climate. What we're looking for is how do you buffer the impact of extremes? How do you make cities sandy ready, if you will? How do you make this exposure to floods, heat waves, mitigate that to some extent with some thinking? Now, with the context about aren't humans changing climate, I agree with you. But where do humans stay? Majority of the humans are staying in cities. So when you do something for cities, cities have often been known as canaries of climate change. The things that happen in cities can happen globally because cities are already 2 to 3 degrees warmer than the surrounding region. So when if you're trying to look for impacts associated with a future warmer world, look no further than a city. So when you're developing tools that can work for a city, perhaps you're providing a template and tools that might be applicable to a much wider community. So both in the context of who is creating the problem, who is in need of the solution, and where can we test the solutions, cities and the ideas that we are talking together really start providing a beautiful observatory and exploratory, if you will, to start putting these ideas together. So I implore people like you to start working more into that area.
Any others?
Well, thank you very much. I'm
Thank
around,
you.
and my email is climate@purdue.edu. If you have any question, I'll be happy to follow. Thank you.